In this short lesson on aircraft wheels, you will learn about the components that make up a wheel and the materials from which a wheel is made. An explanation will also be given of the purpose and function of fusible plugs. The wheels and tyres of an aircraft support it when on the ground and provide it with a means of mobility for takeoff, landing and taxiing. The pneumatic tyres help to cushion the aircraft from shocks due to irregularities in the ground surface and take some of the shock on landing. The main wheels, and in a small number of cases the nose wheels, house brake units which control the movement of the aircraft on the ground and provide a means of deceleration on landing. Because aircraft tyres are usually larger and stiffer than the tyres found on cars, wheels have to be specially designed to facilitate tyre replacement. There are two types of wheel in common use. They are the loose or detachable flange type and the divided wheel. Both the loose and detachable flange types of wheel are made with one flange integral with the wheel body and the other a separate removable part, which is machined to fit over the wheel rim. The difference between the loose and the detachable flange tyres is the method by which the removable flange is secured. In the loose flange type, the flange is retained by a locking device on the wheel rim and held in place by the tyre pressure. The detachable flange type of wheel has the flange secured to the wheel body by nuts and bolts. A detachable flange may be a single piece or 2 or 3 pieces bolted together. The advantage of the loose and the detachable flange type of wheel is that the tyre can be changed without removing the wheel from the aircraft. The type of wheel most usually found on aircraft is the divided wheel. It consists of 2 half wheels matched up and joined together by bolts which pass through the 2 halves. The bolts are fitted with stiff nuts, or, if one half of the wheel is tapped, that is to say that the bolt hole has an internal thread cut in it, then each bolt is locked with a locking plate. In this particular example, the 2 halves are clamped together by bolts fitted with locking nuts and washers. The wheel shown here is designed to be used with a tubeless tyre. It has a seal incorporated at the joint to prevent abrasion between the 2 halves and provide an airtight fit. The inner and outer drive blocks are used to rotate the discs in the multi-disc brake units. These will be discussed in a later lesson. When in service, particularly during heavy braking, there is a tendency for the tyre to rotate or creep around the wheel. This creep, if excessive, will tear out the inflation valve on a wheel fitted with an inner tube, causing the tyre to burst. Creep is less likely to occur if the tyre gas pressure is correctly maintained. The procedures for doing this are explained in the aircraft tyres lesson, but additional features to prevent creep may be incorporated in the design of the wheel, and we'll look at 2 such features now. Wheels are often produced with a knurled flange. The inner face of the wheel flange is milled, so that the side pressure of the tyre locks the tyre walls to the flange. The wheel rim is tapered, so that the flange area is of greater diameter than at the centre of the rim. When the tyre is inflated, the side pressure forces the tyre outwards to grip the rim. Aircraft wheels are either cast or forged, then machined and ground to the required finish. They are made of either aluminium or magnesium alloy. Magnesium alloys are lighter. However, they are subject to corrosion if not correctly treated. And magnesium is flammable, so there is a greater risk of fire. For these reasons, aluminium alloys are normally used, unless low weight is essential. Whichever alloy is used, after initial machining has been carried out, an anti-corrosive treatment is applied, and a final finish using cellulose or epoxy resin paint is applied to each wheel. Wheels for tubeless tyres are similar in construction to those for tyres fitted with inner tubes, but are ground to a finer finish and impregnated with Bakelite to seal the material. Seals are used between the parts of the wheel to prevent leakage. Unlike wheels for tyres fitted with tubes, the valve is fitted into the wheel itself and is thus not affected by creep. Under extra hard braking conditions, the heat generated in the wheel, tyre and brake assembly can be sufficient to cause the pressure to rise to a level that the tyre cannot withstand, causing it to split, with possible catastrophic consequences for the aircraft. This is commonly known as a tyre blowout. To prevent a sudden blowout, fusible plugs or thermal plugs are fitted in some wheels with tubeless tyres. These plugs are screwed into holes in the wheel rim. They are sealed by a piston, which is held in position in the plug by a fusible alloy. Under excessive heat conditions, the alloy melts, allowing the piston to escape. This causes the tyre to deflate in a controlled manner. The important points to be taken from this lesson are related to the fusible plugs. Remember that they are fitted in the wheel rim, and they protect the tyres from explosion due to overheating by releasing the gas in a controlled manner if an excessive temperature is reached.